Mineralogical and gemstone characteristics of natural rubies from the Morogoro area of Tanzania show internal features that can be considered typical of rubies from Burma, such as the color zoning in connection with growth structures and irregular strike-like color distribution, inclusions of negative crystals, spinel inclusions, and rutile seal, which often occurs in regular or irregular zoning in the crystals. Gemological characteristics of this new type of ruby from Tanzania are compared with the properties of rubies from Burma and with the characteristics of a long-known ruby type from the same region of Tanzania, in Burma and Sri Lanka. No special features worth mentioning. However, the microscopic examination revealed that about 70% of the spinels from the new deposit have a diagnostic feature that has not previously been reported in spinels. This characteristic inclusion feature consists of birefringent thin lamellar inclusions, with the lamella planes oriented in 4 sets parallel to the octahedral surfaces of the host spinels. In contrast to the statement described these lamella as irregular growth structuring, electron microscopic examination in conjunction with diffraction experiment showed that the lamella are mineral inclusions of an almost iron-free, titanium-rich member of the hogbomite group. All spinel left orders had a high percentage from stones with the lamella. This result suggests that the spinels come from the common occurrence, were created under equal conditions. Nevertheless, several localities in the Morogoro area in Tanzania have been reported by traders as the deposits of rubies and spinels, such as Amat south of Morogoro, Mahenge southeast of Morogoro, and Gero northwest of Morogoro. Spinels and rubies only occur together in one marble in Matombo, were sorted by the order from several of the spinel lots mentioned. Up to 10% could be red and pink. Rubies are sorted out from the spinel slot. The two similar-looking minerals, namely rubies with a rhombohedral habit and the octahedral spinels, were usually not addressed by dealers as different types of mineral before cutting. As an initial routine examination of the rubies revealed, the stones exhibited a number of characteristic inclusions that were previously considered typical of rubies from Burma. These initial results made a more detailed study of the rubies of this new type appear desirable, due to the fact that determining the origin of polished rubies, sapphires, and emeralds is one of the most difficult tasks in gemstone diagnostics. The authors tried to develop criteria for distinguishing these rubies from those from Burma. Ruby from the Morogoro area differs significantly from a ruby type from Tanzania that has been known for a long time. The external shape of the crystals varies from mostly elongated, flat pieces to cuboid rubies to almost cube-shaped crystals. However, irregularly defined rubies with rounded surface areas were also observed. Individual raw stones can weigh up to 20 carats. The transparency can vary greatly and depends on the inclusion content of the respective crystal. The presence of dense rutile silk in some crystal allows the cutting of star rubies. In terms of external shape, the rubies from the Morogoro area can be divided into 3 main types: crystals with a tabular to cuboid body shape, crystals with a cubic body shape, and heavily corroded crystals with irregularly defined shapes. In the simplest case, if you start with the cube or cuboid consisting of 6 faces and cut off 2 opposite corners of this body, 2 additional triangular faces are created. The crystal then has 8 6 plus 2 faces and at first glance resembles a spinel octahedron. In ruby crystals formed in this way, the 6 faces correspond to the positive rhombohedron and the 2 new triangular faces correspond to the base, determined the morphology of the crystals. In some of the crystals, the 6 surfaces of the prism were also observed, which were developed in different size ratios with respect to the rhombohedral surfaces. This fact explains the similarity in the shape of rubies with dominant rhombohedral surfaces and cubic or cuboid bodies. On the crystal surfaces of the present rubies from Tanzania, from an intense red to lighter pink tones, sometimes with a more or less noticeable violet tinge. On the other hand, only have medium to low transparency. So so that such stones are usually cut as cabochons. However, the transparency of stones of this quality level can be significantly improved by heat treatment, because this dissolves, among other things, opaque, irregularly distributed rutile seal. The raw crystals of the rubies from Tanzania with rounded external shapes and corroded surfaces are clearly reminiscent of the appearance of unpolished rubies from Burma. As the result of successive growth and dissolution processes, such crystals can also exhibit a striking color distribution, which was previously considered a typical feature of rubies from Burma. And stones exhibit strong red fluorescence, whereby clear connection could be demonstrated between the intensity of the red color and the chromium content of the stones. The iron content of the rubies is very low. The absorption spectra of the rubies from the Morogoro area show a typical chromium spectrum without the absorption bands of iron. Absorption minimal are observed in the blue and violet spectral range, as are also known for Burmese rubies. Microscopic features in the gemstone microscope use the immersion technique to recognize growth structure particularly well. They occur parallel to the three morphological dominant crystal surfaces and of the rubies growth structures. With rubies from Burma, however, this surface combination occur frequently in rubies from the Morogoro area. This growth structure therefore represents a locally typical feature for stones from this deposit. Another form of color zoning, the internal growth structure, known as a streak-like color distribution, only occurs occasionally in the stones from Tanzania described. It was previously considered a characteristic feature from rubies from Burma. As the further internal characteristic of rubies from Burma, the negative crystals show a rhombohedral habit and thus reflect the external morphology of the raw crystals. After grinding such inclusion, the cavities intersect the sanded surface. The rubies from Tanzania often have narrow twin lamella embedded in them, which run parallel to the rhombohedral surfaces of the main crystals. In rubies, sets of such lamella are only occasionally oriented parallel to a single one of the three possible rhombohedral surfaces in the crystal, whereas two of the sets of parallel twin lamella often occur. The cut edges of these intersecting narrow lamella can often be seen under the microscope as rod to strip-shaped structures. They are usually covered with a small hogbomite particles, which give structures a light color. Fine fan-shaped to pennant-shaped cracks often occur in connection with the cut edges of twin lamella mentioned, which line up along the cut edges. Rutile inclusions are observed in different forms in the rubies from Morogoro. In addition to these needle-shaped rutile inclusions, fine particles also appear in the rubies examined, which cause a milky cloudiness in many stones. Though growth structures be adjacent areas with varying concentration of rutile needles or dust-like particles were also frequently observed in the stones in these cases. The growth structures run parallel to the morphological dominant crystal surfaces. However, these are occasionally irregular, limited areas with different concentration of rutile or dust-like particles were observed. Changing growth and loosening processes are the causes that create these irregularly defined areas. Zircon occurs in the form of small prisms and rounded crystals and often show the stress cracks typical of this type of inclusion. Apatite forms small prismatic crystals, and puro is found in the form of irregularly defined or rounded mineral grains.